Well, thank you so much. I'm Meg Tirrell, and I'm very excited to be getting to talk with Dr. Bob Langer today. I was just telling Bob, who told me not to call him Dr. Langer backstage, that I had met somebody who knows him well, another scientist in New York a couple days ago, and I said, hey, Mark. I said, I'm going to be talking with Bob Langer. Unfortunately, Francis Collins couldn't make it. And he was like, you're going to be filling in for Francis Collins? That's going to be a different conversation. So I hope I won't disappoint you all. I know that Bob will be magnificent no matter who is asking the questions.
I'm sure you're going to do fantastic.
well, thank you. So just a little bit of background on Bob. If you don't know Bob, he has been called the smartest man in Boston by the Boston Globe in 2003 by my friend Naomi Aoki. He's also been called, this is my favorite, the Edison of medicine, which sounds to me more like something you call like Babe Ruth or something like that. So he has more than 1,000 current and pending patents, which may be the Edison of medicine reference we've been hearing. His lab has given rise to 400 companies with an estimated market value of $23 billion. Excluding Living Proof, which is a hair care company. And actually, I think that's the first time we ever spoke on the phone was about Living Proof. A few years ago, I was writing a story about you for Business Week. And with the potential to touch almost 4.7 billion lives. That was an estimate from Polaris Partners, a venture capital firm you've worked with a lot. So, and you serve on the board of 10 Boston area startups stemming from your work. How do you have time for all of this?
Well, I feel very lucky. You know, we've got a great group of people in the lab, and all the companies. Actually, one of the things I learned early on is if you do everything in Boston, you know, the biggest thing that when I was younger, and I would, fly to California to advise Genentech or companies like that, but that would take a lot of time, because the airplanes would be late and you'd miss them or whatever. And, so many things in Boston now are just like a block or two from MIT, so I can just, walk over to them, and I could, if I needed to do 3 board meetings in a day, I probably could do it. So it's, and the lab, like I say, I almost feel like, we've got such great people. I'm not sure how much they really need me. So.
Well, I'm sure that's not true. But in reading some of these stories about you from this one in 2003, there was this really interesting discussion of Boston and the desire to build it into a hub of research. And looking back now, it seems crazy that it never was that. Yeah. What do you think contributed to Boston's rise in that way and Cambridge's rise in that way? Were there things the local government did, things that universities here did right, that could be emulated elsewhere?
Yeah, well, to me, this may sound highly prejudiced, it probably is. I really think a lot has to do with MIT, and a reasonable amount has to do with Harvard. I don't think it's any accident that... you can see how parochially I am. But at any rate, I don't think it's, when I look at the United States, it's interesting. The 2 biggest places for, small company innovation have been, the area around Stanford and the area around MIT. Both are, very good universities. Both have kind of like this engineering culture to a certain extent. So I think a lot of it has to do with being near great universities. And that's just the catalyst. I think once the companies get started, lots of other things come, right? Venture capital, lawyers, all kinds of things. I think the governments haven't stood in their way, and sometimes they've been helpful. But I think by and large, it's I think those universities having some land adjacent to the universities, I think has also helped. Originally in Cambridge, there was going to be the Space Center, years ago, was going to be right near MIT, and that didn't happen. So that also left open the opportunity, for companies to get built. But now what's happening in Boston is, since the rent's so high right near in Kendall Square, people move, to Seaport area, Waltham, all over the place, and all those areas start doing better and better too.
Do you see any sort of drawback to the rents getting so high? You hear about sort of Kendall Square becoming gentrified to the smaller sort of startup companies. Is there a way to make sure that that sort of atmosphere is still being fostered?
Yeah, I think that's a great question, and I think we are concerned about that. So at MIT, they just are doing this thing, creating what's called the engine. They're going to put like $150 million into it and try to facilitate young people, like students, starting companies and things like that. But it's gotten more and more expensive, and and it's draw in so many people. So if somebody comes in from, say, the Midwest even, and they have to like live in Boston or New York or places like that, I mean, it's a big change.
Mm-hmm. I read in one of these stories about you that one of the places from which you draw inspiration is TV shows. What shows?
Well, that'll be embarrassing, but let's say. Well, I mean, I guess now the ones that I probably watch, most, I probably watch like Law and Order and Law and Order SVU. I've always liked those have been good shows. I used to watch a lot of comedies like. Mary Tyler Moore and Dick Van Dyke. I don't know how many ideas I got from those, but sometimes you see things. Like I exercise a lot, so I'm on the exercise bike and I have the TV on and I'm working, and I usually I have to do 3 or 4 things at once. So so sometimes things just pop into your head when you're watching something.
Mm-hmm. And what are you most proud of that's come out of your lab that you've developed?
Well, I think you could look at it 2 ways. The number one thing I'm most proud of are my students. I mean, and I guess that they've come out of the lab. I mean, and we have like 300 of the students are professors at universities all over the world. They're deans, and a lot of them have started companies or CEOs, and are heads of research. And I mean, 14 are in the National Academy of Engineering, 12 in the National Academy of Medicine. I mean, so they've done fantastic, and they keep training more and more people and starting more and more companies. And so that's the number one thing that I'm proudest of. It's like a big extended family. In terms of science, I mean, there's a few things. I mean, one was the ideas really goes back 40 years ago where we made discoveries on how you could use polymers to release molecules of almost any size for really long times. And that also enabled me to, and this was with my postdoctoral advisor, Judah Folkman, to isolate the first substances that would stop blood vessels from growing. And that's led to all kinds of medical treatments. And then the other big area was sort of with Jay Vacanti, who's at Mass General, coming up with this idea of what's now called tissue engineering, where you could use polymers and sometimes cells to make new skin for burn victims and hopefully make anything someday.
One of the cues I picked up on from reading about your group is that you not only look for rock stars in many different fields, but also nice people. This might be the bias of somebody who's lived in New York for 10 years, thinking you don't have to be nice to do a good job. Why do you need nice people around? Why does it matter?
Well, I think there's two reasons. One, I mean, this is almost a selfish reason for me. If somebody's not a nice person, they create such a problem in the lab. And I remember one time I had this back in like 1979, and there was this one person and nobody could stand the person, so I had to have the person move eventually to another lab.
How'd you sell them to that lab?
Well, I said, you get your
The work is really great.
No. I said they get their own lab space, right? So they had a lot more lab space. And, for anybody doing lab work, lab space is a big deal. But trying to resolve conflict, I mean, I don't like that, but you have to do it. And if somebody's not nice, that's the problem. I think the second thing is, like, we do a lot with teams. I mean, the work we do is super interdisciplinary. And so if people don't get along, it makes it really hard. And, and I think so if somebody's not nice, I mean, I think it just creates so much difficulty for everybody sort of pulling together to try to, drive a project through.
Mm-hmm. As you look out in your own lab and also just in the world of science right now, what most excites you?
Well, I think there's a lot of things that are really exciting to me now. I mean, one thing, and I'll make some connections in a second, is say the area of nanotechnology. I think that is very exciting. And one of the reasons it's exciting is it gets to another area, which are all these new genetic therapies that are going on, like siRNA, mRNA, gene editing approaches. To try to make them work, though, you have to be able to deliver those substances to cells in the right way, and that's often hugely complicated. And nanoparticles are probably, one of the, maybe the best way to do it, and then trying to figure out how to do that right ends up being a big deal. So I think that those two areas, in different ways are certainly one of the things. I think a whole other thing that's exciting to me is this area of regenerative medicine, tissue engineering. Could we make new body parts from scratch someday?
How do you look at the progress that's been made in regenerative medicine? It seems there's so much promise there, but maybe it hasn't gone as fast as other areas.
Yeah, well, I'd say a lot of areas haven't gone as fast as we want. I think that's one of the problems in medicine.
Called faster cures here. Yeah.
Exactly. And I think that which is great that you couldn't ask for something better. But I think regenerative medicine in many areas, I think, just haven't gone as fast as we want. And there's scientific issues, there's regulatory issues, there's money issues. I mean, the research is really complicated. And again, if you try to do this, and I think this has also been true for cancer, which certainly hasn't gone as fast as we want either, like if you have to do tests on humans to figure it out, it's going to be super slow. And if you don't have the right animal models, and very often we don't, I think it just makes it really, really hard to make progress as fast as you want.
Is work being done to fix those problems? I mean, those seem like more just problems that it's not a problem of the science, it's not a problem of figuring something out, it's just a matter of having the resources and the time to do it.
Well, I think it's complicated. I think, so people, including ourselves, you work on creating like organs on a chip or things like that. But the problem is if you do that kind of thing, you still miss a lot of things that are going to be in the person, right? You probably don't have the immune system. You may not have the vasculature. You may not have extracellular matrix. I mean, there's a lot of things you miss. If you take the animal, I mean, no animal's the same as a person. People do the best they can. And then even when you start to deal with people, all people are different, and that's why sometimes you see, maybe a phase 2 trial looks good and the phase 3 trial doesn't look as good. So a lot of things go on to try to fix it, but it's slow. I mean, and it is costly, and I think there's just so much more we need to understand.
Do you see a sort of government support for science right now, and the right kind of government support?
Well, I think there's a concern about government support. I think we'll see. I mean, that would be a good thing for Francis. I think he'd be able to address that far better than I. But I think there's a concern about how much government support there will be, for really good research. I think we'll just have to see. I mean, to me, what the NIH has done over the years in terms of support has been critical to advancing science, advancing medicine, to creating the core technologies for so many of the startup companies and now like a lot of them aren't startup anymore. I mean, they're much bigger. So I think we'll have to see.
When you look at the NIH, there's been a focus under Dr. Collins on translational research. How do you think about translational research versus basic research happening within NIH-funded projects? How do you think that should be done?
Well, I think you need some balance. I think basic research is absolutely critical for so many things. But translational research is really important too, and it gets to some of the things that you just said. How do you, try to solve a problem on human beings? So I think you need both. I actually feel when I look at it overall, there's been, over the last 40 years that I've been doing research, I actually feel they've done a pretty good job of balancing it. And I think really what you want to fund is really good research or really great research. And it could be great basic research, it could be great translational research. So I think that you want to just, and so I feel overall they've done a good job. I mean, but great research is really the key, whether it's basic or applied.
Have you seen any of the sort of the warnings that we hear about a lot, that young people will be deterred from pursuing science because of this uncertainty around getting grants?
I think that's a concern. Yeah, I have heard that. And you do hear it some. I still think, when I look at the people in our lab and I look at young people, an awful lot of people are excited about science, but, people, I think more can be done. I don't think it's just about grants. I think, and I think it's also, it's almost part of the culture. People say a society gets what it celebrates, and I think what happens is that a lot of young people, they read, well, they can make a lot of money if they're running a hedge fund, or they could be a movie star or a singer, and or a sports star. And I think that grants are one thing, but I think also, just the aura of being how does somebody decide whether they should be a hedge fund manager or a scientist? I hate it to be about money, but sometimes it is for people. You have students come in and their parents tell them, well, you have to get a job that makes a lot of money. And so I think that there's a lot of issues that go into students' minds when they try to make a decision.
Do you think that can be fixed?
Well, actually, I feel one place that can help is the media. I think another place that can help is the government. I do feel that it can, I don't know if it can ever be fully fixed, but it's interesting. When I was young, what everybody said to their little kids was that you should be a medical doctor. That was something where people made a lot of money and you could do good. Today a lot of people, they tell their kids, well, you should be a hedge fund manager. And I think that, so, I mean, I would certainly love to see, for example, grammar school teachers and high school teachers get paid more money. I mean, people that really affect children's lives. I mean, that would be a good thing. And I think states and the federal government, can obviously help on that. But also, I think the media can celebrate those people too, whether it's TV shows or the newspapers. And those people, just have a profound effect on children's lives. So I think that I think it can be improved. Whether it could be fixed, that's hard to say.
Speaking of one TV show, there was rumor, and I don't know what happened with this show, but there was supposed to be some Jennifer Lopez TV show called CRISPR. Had you guys heard about this? She was going to make this whole show called CRISPR. So, I mean, that could be pretty cool.
Yeah, that would be great. That would be very neat. I'm not sure what it's about, but we'll see.
I don't know either. Speaking of CRISPR, like my segue, what are your expectations for what that technology will do? Do you think that it will make a big difference in human medicine, or will it stay in the area where it's proven to be extremely useful already in the lab?
I think it'll do both. That's not to say that there won't be significant new advances that could, even be better than CRISPR someday. I mean, before CRISPR, there were things like, zinc fingers and things like that, but people keep coming up with better discoveries, better inventions. But I think, gene editing is certainly here to stay, and I think will certainly have a profound effect on, a lot of treatments.
What do you think the limitations to it are?
Well, I think that gets back to one of the things that I said before about delivery systems. If you really are trying, it's still not simple. If you try to do something in a human being or even in an animal, how do you get CRISPR-Cas9? How do you get them to the right place and get them to do the things together that you want them to do with reasonable efficiency and with reasonable safety? I mean, so I think there are lots of limitations, but people are working on overcoming them, and it's one of the things we do in our lab too. But I think that's. So I think there's still a tremendous amount to do.
Do you think we understand our genetics well enough to really use CRISPR well?
I think we understand it well enough to use it in certain cases. I think right now, there's certain areas that we understand the genetic. Like people are looking at certain types of eye diseases and things like that. So I think there are particular areas where we know it well enough, but there's an awful lot we don't.
How do you look at the idea of germline editing?
Well, I think that's complicated. I think the question is what one is going to really do. I mean, there's so many aspects to that. What one's goals are, what's one going to really do with that. What are you trying to achieve exactly?
Does it concern you?
Well, it certainly concerns me if we end up making things that are bad.
Right.
And so I think that so I think people will put, I'm sure things will be put in place, certainly in this country, to make sure that doesn't happen. I mean, you can never be perfect, but I think things will be put into place to, people are already, working on those kinds of things.
Is this situation so different from what happened around recombinant DNA and people just thinking about the possibilities of that and being worried about the possibilities of that?
Well, I think all these things, I think with radioactivity, with your point about DNA, so many times, I've seen this with nanotechnology too. People sometimes get scared. They don't know what can happen. And so I think there needs to be a lot of thought put into making sure, that what we do is safe. And so in that sense, what you're saying is exactly right. I mean, every time a brand new technology comes up, I think it's important that people step back and, make sure that we use it safely and thoughtfully.
As we're thinking about accelerating treatments to patients at this conference, is there something you've observed in your advisory work or in your own companies or work in the lab that you see, well, that's one thing that just doesn't need to happen. We can speed this up. We just need to stop doing this or start doing this?
Yeah. Well, I think, one of the big challenges always is how do you accelerate things at the FDA? I think that's and it's complicated because you want to do things safely. But I think the more, and I know that at the FDA, they give a lot of thought to this too. How can you, speed it up? I mean, having more people, having, timelines that are faster, trying to fast track more things. I think that the human testing is by far the thing that slows things up the most.
Mm. And in terms of the FDA trying to balance that, we have seen a lot of action from them recently. Do you think the shifting to real-world evidence, to trying to give at least sort of a conditional approval early and then continue the testing afterwards, is that a step in the right direction?
I think it is. I think it is. Again, you have to make sure that you have to make sure that the data is good. That things are science-based. I think that's really the key for any of these things. But if it is, I think getting approvals and getting these things out to patients sooner rather than later is the right thing to do.
Mm-hmm. In your own career, as you look back, is there one big mistake you made?
Oh, geez, I probably made a lot.
One that might serve as a lesson.
Yeah. Well, I could sort of think about it in different standpoints. From an academic standpoint, I ended up making probably a lot of mistakes. I'm a chemical engineer, but then I really didn't, but I wasn't that excited about really doing standard chemical engineering. And and when I got done, most of my friends went to oil companies, and so I thought I would do that too, but then I wasn't excited about it. So, I think if I had given more thought early in my career to what was out there, that might have probably helped me, but it was really hard to know. I mean, I feel like I learned a lot from exploring, from going to these interviews, even from teaching me what I didn't like. But I don't feel like it took me a really long time to figure out what I want to do with my life. And I think that's hard for students. So if there was some way that I could have figured it out earlier, that would have probably been better.
Well, it seems to have worked out all right.
well, thanks. But I think it's you learn from to me when I look back. I mean, I'm glad that I've had some of those experiences because you learn from them. And I often tell my students that it's good to learn what you don't want to do as well as what you do want to do. Sometimes that helps push you in the right direction.
Mm. As you look forward, is there one main goal you have? One thing you really want to accomplish or work on?
Well, I always have, there's actually three, I'll do them fast. One is coming up with more new ideas that I hope will have a big effect on the world. We're doing a lot actually now in even third world medicine with the Gates Foundation. The second is bringing more and more technologies into the clinic, that we've started. And the third is training future leaders, that'll go out and hopefully make the world a lot better place, the students and postdocs who are working in the lab right now.
Wonderful. Well, we're just about out of time. Bob
Great.
Langer, thank you so much.
Thank you very much.
Thank you all.
Thank you.